Hi, welcome to the Abbey Road Observatory. I'm your host, Jim the Filter Guy. Have you ever wondered what in the world is a histogram? Well, that is the topic of today's video. In it, I will explain what exactly a histogram is, where it comes from, and how you can use it to improve your image data gathering and post-processing. But before we begin that, if you would like to stay in touch with the ARO and know everything that we're up to, why don't you take a moment and subscribe to the channel down below. All right, well, let's get the show on the road talking about what the heck is a histogram and how do I use it. Hello, and welcome to my video today titled, What the Heck is a Histogram and How to Use It. You probably all heard the term histogram used in conjunction with discussions about image processing. In this short talk, I will hopefully clear up any questions about what exactly a histogram is and why it is so useful. If you go and look up in the dictionary what a histogram is, you get the following definition. A graphical representation of the frequency distribution of a variable in a body of data. Kind of a dry explanation that doesn't really help you. But if we break it down and relate it specifically to the context of digital images, we can make the following connections. Frequency is the number of times the parameter of interest is occurring in your image. The variable in particular we're looking at is the pixel brightness or color value. And the data set we're talking about is the image itself and all of the pixels it contains. Let's make it very simple and look at this happy little image here that I put together. It's a 4-bit grayscale image, so the pixels can have a brightness or luminance value from 0 to 15. I've limited it to a fairly small number of pixels, so it's easy to get a grasp of what we are talking about. Now, if we examine each of the pixels and figure out what grayscale level they have, and then count them all, we see that the image has 5 pixels at grayscale level 8, 8 pixels at grayscale level 0, and 12 pixels at grayscale level 15. I am literally just counting how many pixels of each grayscale level there are in the image. If we now plot those pixel counts as a bar graph, that is a histogram. In the histogram, you can see the number of black pixels, the number of gray pixels, and the number of white pixels. And that's all there is to it. Simple, right? Here is another example image, this time with a few more pixels. The image shows a nice gradient of pixel values from 0 to 15 that is repeated 4 times. If we count the number of pixels at each grayscale value, in this case there being 4 of each, we get a histogram that looks like this. Again, pretty straightforward. Let's now go a step further and look at a more complex image. This is a picture of Tycho crater on the moon taken by the Lunar Reconnaissance Orbiter. It's an 8-bit grayscale image, so there are pixel values from 0 to 255. This is what the histogram looks like for this image. Along the bottom of the histogram, we have the numbering of the bins, one for each of the grayscale levels from 0 to 255. Depending on what the bit depth of your image is, you'll have a different number of bins. 16 bins for 4-bit, 256 for 8, 4096 for 12-bit, 16,384 for 14-bit, and 65,536 for 16-bit. Along the y-axis is the number of pixels in the image at each of those levels. Using the histogram, we can see that for grayscale level 0, so over here, there are quite a few pixels in the image at that level. Probably about, say, 200,000 pixels. Those are all the pixels in the image that are black. Now, most often in software that you are using for manipulating or for collecting your images, you'll see the histogram drawn simply as a line. But it's still giving you exactly the same information. So what does the histogram tell us about our image? It gives you an idea of how the intensity of pixels is distributed, how many dark pixels you have, how many light pixels you have, and how many in the middle. You can use this information to do things like figure out if you're losing information at the dark end or light end of your image, which we call saturation or clipping. You can figure out if you are completely using up all of your possible dynamic range, whether it is from 0 to 255 for an 8-bit image, or 0 to 65,000 for a 16-bit. You can also use a histogram to tell how well color balanced your image is when you compare the histogram for each of the image's color channels. What the histogram does not tell you is where those pixels are located in the image. For example, these two images on the bottom of the screen have exactly the same histogram. Let's explore the uses I mentioned for a histogram, starting with looking for clipping or saturation. Here we have an image that many of us would consider to be too dark. That image property shows up quite clearly in the histogram by the data being shoved way over to the left-hand side. You can see there's even a little roll-up right here, where the data increases suddenly towards 0. That's a clear indication that we are clipping off data from the image on the dark end. Similarly, if you look at an image that's too bright, you get the same roll-up at the light end, showing that we are losing information from the image because it is too bright. It's saturated. Now, just like the story of Goldilocks, there is an image that's just right. Here you can see there's no roll-up at the ends. The data rolls gently down towards 0 or to some low value at each end. That is a well-adjusted histogram for this particular image. Now let's look at another use for a histogram, examining the dynamic range of your image. If you're collecting image data in as effective a manner as you can, your pixel values will be distributed across the entire range of possible values. Take, as an example, this image I took of the moon. It looks a little flat, and the histogram shows the pixel values are kind of scrunched together. The peaks in the middle are very pointy. And there's a gap over here on the dark end where there's no data. So all of these bits here in my image are empty. I'm not making use of them, so this isn't an effective use of the available bit depth. Similarly, an image that's too bright and contrasty. The image peaks are now all stretched out and there is clipping at either end. Thus, I'm losing information off either end of the image, not making proper use of the available bit depth. Now, if I try to do a proper job of adjusting the dynamic range of the image, we get this. The histogram now has nicely rounded peaks, and the data rolls down nicely towards 0 on either end. But even this image isn't quite perfect. There's still a small gap here in the data, but it's much better than the first image. Knowing this is very useful when you are collecting your image data. When I'm collecting moon image data in particular, because of the object's inherently large dynamic range, having a live histogram up on the screen in your software is very helpful for adjusting camera settings to make sure that you're not losing any data, but you're also capturing as resolute a data set as you can. Now for a few notes on color images. It's exactly the same as for the grayscale images, except that there is a histogram for each color channel. So if it's a red, green, blue image, a cyan, magenta, yellow, black image, or a hue, saturation, luminance image, there will be a histogram for each channel. You can manipulate each of those channels independently of each other, which allows you to have a lot of control over the color balance of your image, highlight certain areas by color, or do things like false coloring. You can do all kinds of interesting tricks to pull out detail in your image. The overall brightness of the image, called the luminance, in a color image is a weighted average of the color channels. It varies depending on the camera and its Bayer matrix configuration, but it is basically some sort of weighted average of each color. There are lots of tools available in software today to allow you to play with your histogram and make adjustments. The tools come with many different names. Brightness and contrast are probably the two most common adjustments you can make, followed by gamma. There's a group of tools called tone balancing, tone mapping, or curves. They're all kind of similar. There's also dark point, white point adjustments, or shadow, mid-tone, highlight adjustments. These image processing tools have different names, but they essentially do very similar things to the histogram. To give you a better understanding of what these tools are doing, I'm going to go through a couple of the more common tools that are used. First, brightness and contrast. Here's a series of Mars images across the top of the screen. I've adjusted the brightness just using a simple photo editing software. You can see how the histogram changes as you go from dark brightness adjustment up to bright adjustment. It's essentially stretching the whole histogram, pulling it out to the right as you increase brightness. All the pixel values in the image go up as you increase brightness. Contrast is a little different. This adjustment stretches the histogram, but it's stretching both ends at the same time. The dark areas of the image get darker and the bright areas get brighter. You can push all the data together into a narrow range, or you can pull it all out to better fill the bit range of your image. You can see from the histograms what happens if you go too far with these adjustments. In the case of the brightness, pixel values are getting piled up here on the right-hand end, and it's starting to clip the data. Similarly, the contrast, in this case, I pulled it too far here, and I'm starting to lose data off of the dark end. You can see the roll up here. which is why we see more black areas on the image on the right than on the left. Another tool that is very handy to use is gamma adjust. You've probably seen the term before when you're adjusting the brightness of your monitor trying to play a video game or something. Here is an example of the gamma being adjusted on that same Mars image. It's a way of adjusting the way the mid-tones of the image are distributed. Gamma adjust doesn't change the dark end or light end of the image, it just shifts the center of the histogram left or right. As a result, you can make, depending on how the data is distributed, the overall image look darker but more contrasty, or the opposite, bright and more flat. It's very similar to playing with the brightness, but it ends up not causing any saturation. I find this adjustment extremely useful when imaging very faint objects such as nebulae. By moving the histogram midpoint to the right, or less gamma, it brightens faint nebulosity and makes it easier to see. Now let's get into a little bit more advanced tool that you can find in editing software, the tone balance. This is an example user interface from the software that I use. There are 3 adjustments that you can play with: the shadows, or black point, the midtones, and the highlights, or white point. They all have adjustment sliders that you can move around. You can move them together as a group, or you can move them independently of each other. You can also pick the channel that you want to work on. You can work on the overall brightness of the image, or if it's a color image, you can pick the individual color channels you want to adjust. It's your choice, based on what you're trying to achieve. To interpret what the tool is actually doing, take note of the histogram that is plotted in the middle of the tool window. Where you position, say, the shadow slider is where you are telling the software you want black to be. Everything to the left of the black marker will be black, clipped at black. Similarly, where you position the highlight marker says where you want white to be. Everything to the right of the marker will be clipped at white. Everything in between the shadow and highlight markers gets stretched accordingly to refill in the bit range of your output image. The midtone slider is basically the same as a gamma adjustment. If you move the midtone slider left, more of the histogram is to the right of the midpoint, so it makes the image brighter. And similarly, if you move the slider to the right, more of the histogram is to the left of the marker, making the image darker. There are different variations of this tool, or the names used to describe it, depending on what software you're using, but they all can do essentially the same thing. Kicking the fanciness up a notch, let's now consider the Curves tool. It gives perhaps the ultimate control over what your image looks like. Here is a screen grab, again from the image editing tool that I use. The histogram plot and overlaid line is a map showing how you want different pixel levels in your input image to be translated to produce the output image. So for example, all the pixels at this intensity level in your image will be changed to have this level in the output image instead. The line represents the translation between input and output. By default, when you open the tool, it is a straight diagonal line, meaning a one-to-one mapping from input to output. Basically, no changes are being made. But if you start moving these little handles here, one at the bottom, one at the top, changing the position of this line, you change the way your data is mapped to the output image. Some of the examples are, if you move the whole line up, it makes the image brighter. If you move the whole line down, it makes it darker. If you make it more vertical, you're increasing the contrast. And if you make it more horizontal, you're lowering contrast. Now, if you add a new handle to the line in the middle, say here, it gives you another way of adjusting the curve, in this case, adjusting the midtones or gamma. And if you're really adventurous, you can add multiple points on the curve and adjust them all independently. You can see the mapping in this example is quite weird, with all of the bright pixels up here and all the dark pixels mapped not too differently from the input image, but the mid-range here is being mapped to something brighter than the input image. This tool gives you the ability to perform some very powerful adjustments to your image. Thus, you can achieve all the same adjustments from the simpler tools, brightness, contrast, gamma, etc. But you also have additional functionality, all using this one tool. Well, that's it. Thank you for watching. If you have any questions, please feel free to leave a comment below. Or you can send me an email at the address provided in my channel description. If you have enjoyed this video, please take a moment to click the like button. And if you would like to stay connected to everything the ARO is doing, perhaps you would like to subscribe to my channel. From the Abbey Road Observatory, this is Jim the Filter Guy, wishing everyone clear skies.